Okay, in today's session, we will see about an two-dimensional array. In last session, we have covered a single-dimensional array. So, in the single-dimensional array, we have performed an operation of an insertion at different positions and then deletion at different positions. So, then today we will see about two-dimensional array. So, generally, the array means what? It's a linear data structure type. So, where here it will store the data in types of continuous memory. That's a linear data structure. And then the application of arrays, it can be used for to store a data in sequential way. Best example is your records. Whatever records, for example, if we have 60 number of students, then for 60 number of students, I want to maintain a data for each every subject. Then I can use a simple one-dimensional array. Then if I want to go for two-dimensional array, means the best example is matrices or some rectangular tables. Okay, so otherwise for sorting purpose, I can use an arrays. Otherwise for an strings, stacks, queues, and heaps, I can use an array. Okay, a stack also I can implement a stack using an array. Otherwise, some strings or heaps, I can use an arrays. These are application of arrays. So the application of arrays is always about an you can confine more about on one-dimensional and two-dimensional. One-dimensional means maintaining records. Two-dimensional means matrices, tables, all those things. So in two-dimensional arrays, generally we have an rows and columns. We have an rows and columns. So how do you mention these rows and columns? Okay, for example, if I take a type of an integer, a of, I will mention by means of two square brackets. Two square brackets. So always the first one will indicates it is a row and second one will indicate it is a column. First one is always indicates for rows and second one is always indicates for column. So for example, I am giving integer is a type and where A is the corresponding matrix name and then the number of rows I want is 2 and number of columns I want is 3. So this is one way of implementing this one way of defining your corresponding two-dimensional array. The other example you can see here int a of 2 and 3. Here itself I can give those values 1 comma 2 comma 3 which is for first row, which is for first row, and 4 comma 5 comma 6 is for second row. Okay, so here what happens over here? The 1 2 3 we have three columns and 4 5 6 we have three column values, and this will form this 1 2 3 will form one row and this 4 5 6 will form another row. This is another way of defining your two-dimensional arrays. Then int a of square brackets and square brackets I have 3. So it will define this isn't wrong define it is. Why it is? Because in the when you're defining the two-dimensional arrays, always the row is must. Okay, so the for example the columns is always must. The columns is always must. So now here this is correct. So where here we have mentioned the column, we have mentioned the column. So it is correct. So now what happens over here? I can increase the rows as much as I want, but the column will be always defined as a 3. Then in another example, if I mention a of 2 and square brackets, then is it right or wrong? This is the wrong one because the column size is always required, but whereas here the column size is very much blank. So this is the wrong definition. It's a wrong define. Understood? So this is how we can declare the corresponding rows and columns in terms of arrays. Okay. So now we will see the application of two-dimensional arrays. Okay. So then application of two-dimensional array. The example which we are going to see here today is it's about and sparse matrix. So generally we have seen a matrix. In the matrix we have in rows and columns. In the rows and columns we have in different types of values. That is a matrix. So what is sparse matrix? It's all about having a greater number of zero elements than a non-zero elements. That is called sparse matrix. Having a greater number of zero elements than non-zero elements. This is called sparse matrix. So here, let me show an example. So let me consider this as a matrix. Okay, where here the size is the number of rows are here is 4 rows and the columns are 3 columns. So the size of a matrix is rows into columns for 4 cross 3. Okay, where the rows is 4 and column is 3. So now here I have values and 0, 0, 1, 0, 0, 0, 0. So now here in this matrix, we can observe that there are more number of zero elements. There are more number of zero elements. Then if there are more number of zero elements, then I need to allocate a memory space for all the zero elements and then all the non-zero elements. Then it's a wastage of memory. It's a wastage of memory. Okay, so for example, it occupies an memory space of uh, 4 bytes, 4 bytes, 4 bytes. So this row occupies 12 bytes. This 2 rows occupies 24 bytes. This 4 rows occupies 48 bytes. Okay, so here it's a wastage of memory. So to overcome this problem in the sparse matrix, we have gone for an corresponding triplet representation. Triplet representation. So what is meant by triplet representation here? Okay, so now here, whatever in the sparse matrix, whichever is a non-zero elements, I will take those non-zero elements alone separately, and then I'll put it in a table. That is called triplet representation. So in the triplet representation, we have an predefined 3 columns will be there. There will be predefined 3 columns will be there. One is for a row, and other one is for column, and the last one is for value or data. Value or data. So these are the predefined. Always the column size is 3, where the row size will define or will change depends on the number of non-zero elements. Depends on number of non-zero elements. So now here for first example, in the first row always we will mention the size of a matrix. Size of a matrix. So here the size of matrix is 4 cross 3. So now here the number of rows which are in the size of a matrix is number of rows. How many number of rows are there? This matrix size is number of rows are 4 rows. So here I will mention the 4. And how many columns are there in this matrix? 3 columns. So I mention here 3 column. And then how many number of non-zero elements are here? So 1, 2, and 3. There are 3 non-zero elements are there. So now here the first row defines the number of non-zero elements in a sparse matrix, and then it will define the size of a sparse matrix. That's what first row purpose. And then from second row onwards, we will define that at which position the non-zero elements holds in a sparse matrix. So now, for example, this position take it over here. So now this question is all about this is in first row and third column. This question is first row and third column. So whereas here this is second row and second column. This is third row and first column. So now in the place of row, I mentioned the first row and third column, and the data is 1. And then second row, second column, and data is 7. And then third row, first column, the data is 8. Data is 8. So this is called an triplet representation. So now what happens over here, usually by means of sparse matrix, it would have occupied 48 bytes. A normal matrix would have occupied 48 bytes. So now we have reduced by means of, in the triplet representation, we have reduced by means of a large amount of memory over there. That's the advantage of an triplet representation. The sparse matrix is an application of your two-dimensional array. So general matrices. So we have taken as a sparse matrix as example, and then we have seen the drawback of in the sparse matrix, and then we have seen how can we overcome the drawback by means of triplet representation. Okay, in the next video, we will see about how can we program the sparse matrix into triplet representation. At first, we will program the sparse matrix, and then followed by we will program how to convert the sparse matrix into triplet representation.